Hello students, in this video we are going to discuss rule 2 in which we are going to evaluate particular integral f of d q when q is equal to sine ax or cosine ax, right? So we know if we differentiate sine ax or cos ax one time, we get minus a plus a cosine ax, right? But if we differentiate this two time, we get minus a square sine sine ax again, right? So therefore you can see from here, if we replace we can replace d square by minus a square as we did in the last video, right? So I'm not going to the nitty-gritty of this concept, right? I mean to say, I'm not going to the depth of this proof, right? So I'm just writing this rule in brief. Okay, in this we f of d square sine ax is equal to f of minus a square sine ax, right? So this is rule number 2. Or same this can be also extended to cos ax, because same property is true for the cos ax. So f d square cos ax is equal to f minus a square cos ax. So you just keep this thing in your mind, because coming problem will be solved using this rule, right? Also case of the failure, if 1 upon, or you say if f of minus a square is equal to 0, then we will have to find out integral particular integral by particular integral f of d square cos ax or sin ax. We will be differentiating derivative with respect to d. Okay, then again we will be applying the above rule, right? So let us illustrate this thing with an example. Okay, yes, solve given equations. A symbolic form is d cube plus d square minus d minus 1. Okay, y equal to sine 2x. Auxiliary equation is d cube plus d square minus d minus 1 equal to 0. So this is cubic equation. So first root will be we are going to find out first root by hit and trial method, because like we did in the last example of the first rule, right? So in that we just tried okay, so in this we are going to try 0 1 2 3, minus 1 minus 2 minus 3, okay, so on. So whichever fits in, we are going to take that a root of the given auxiliary equation, right? So firstly 0, let us set d is equal to 0. If we set d is equal to 0, then it is not equal to 0, therefore d is equal to 0 is not an root, because if we set d is equal to 0, we get minus 1 is equal to 0, which is not true. Okay, so d is equal to 0 is not a root. Okay, if we set d is equal to 1, then this becomes 0, right? 1 1 minus 1 minus 1, so 0 is equal to 0, so therefore d is equal to 1 is one of the root. Therefore since, okay, d is equal to, okay, you just directly write d is equal to 1 is one of the one root of the equation. So we know how to find out the rest of the roots, okay, by synthetic division. Write the coefficient of given cubic differential equation, okay, 1 1 minus 1 minus 1, and 1 is the root, so 1 1 1, okay, 1 into 1 1 again, okay, one second. So 2 into 1 2, so it is 1 1 into 1 1 and 0. So rest of the two roots will be given by d square plus 2d plus 1, okay. Therefore you can write by synthetic division or Horner method, synthetic division, we see that rest of the two roots are given by d square plus 2d plus 1 equal to 0. So easily you can see it is whole square of d plus 1 equal to, okay, so it is equal to 0, right? So therefore two roots are minus 1 and minus 1. Therefore writing all the three roots in one go, okay, we get d is equal to 1 minus 1 and minus 1. Therefore or complementary solution is c1 e raised to power x plus c, ये क्या है, repeated roots हैं, therefore we will have to multiply with x for the when we are going to write minus 1 second time, okay. c2 e raised to power minus x plus c2 x e raised to power minus x, so we added, okay, we multiplied third term with x, right, because it was a repeating root, okay. So this is complementary solution. Now let us find out particular integral. So particular integral would be equal to 1 over d cube plus d square minus d minus 1 sine 2x, okay. So it is equal to, now as you can see, when here we are having sine 2x, so in this case we are going to replace d square by minus a square as per the rule number 2, okay. So d cube, see, d cube is equal to d square into d, so d square would be replaced by minus 2 square, okay. So minus 2 square into d minus 2 square, okay, minus d as it is, minus 1 as it is. Okay, sine 2x, 1 over minus 4d minus 4 minus d minus 1 sine 2x equal to 1 over minus 5d minus 5 sine 2x, right? So again we want to get somehow square here. Okay, so in order to get that, we are going to multiply and divide by. Okay, firstly take minus sign outside of this thing. Okay, so minus taken out, we get 5d plus 5, or you also take 5 outside the bracket, so we will be having d plus 1 inside. Okay, and sine 2x. Okay, now in order to get square here, we are going to multiply and divide with d minus 1, d minus 1. Okay, so in this way, minus 1 over 5, d minus 1 inside, and it would be getting squared. So we know it is equal to d square minus 1 sine 2x, right? So it is equal to minus 1 over 5 d minus 1, and you know now we can replace this by minus 2 square, which is minus 4. Okay, minus 4 minus 1 sine 2x. So it is minus 5, taking it outside, it becomes minus minus plus 1 over 25 and d minus 1 into 2x. Okay, so it is equal to 1 over 25 d sine 2x minus sine 2x. So we know d stands for differentiation. Okay, right? So therefore it is equal to 1 over 25 to cos 2x minus sine 2x. Okay, so this is the particular integral. Now complete solution is equal to yc plus yp. So adding both, we get y is equal to c1 e raised to power x plus c2 e raised to power minus x plus c3 x e raised to power minus x plus 1 over 25 to cos 2x minus sine 2x. This is the solution of which is the required solution of given differential equation, right? So this is the first problem on this rule, right? When q is equal to sin ax or cos ax. Okay, now we are going to take second problem number 2. Okay, or you say exercise 2. So in this we are clubbing the rule number 1 and rule number 2. Okay, we will have to use both the rules in this problem. Okay, so here double derivative with respect to solve. Okay, solve y double dash minus 4 y single dash plus 4y equal to ex plus sine 2x. Okay, so here symbolic form is d square minus 4d plus 4 y equal to e raised to power x plus sine 2x. Auxiliary equation is d square minus 4d plus 4 is equal to 0. Now what are the roots of this equation? Usually this equation can be written as d minus 2 whole square equal to 0. So therefore d is equal to 2 and 2 are the two roots. So repeated roots, therefore complementary function is c1 e raised to power 2x plus c2 x e raised to power 2x, right? Now let us try to find out the particular integral, which is equal to d square minus 4 d plus 4. Okay, and here you are having ex plus sine 2x. So it is equal to 1 over d square minus 4d plus 4 ex plus 1 over d square minus 4d plus 4 sine 2x, right? So see here q is equal to ex. So we will be applying first rule here. Here q is equal to sine 2x. We will be applying rule 2 here. Okay. So in rule 1 we used to do what? We used to replace d by a. Okay. So do the same here. So in this d square will be replaced by 1. Okay. So 1 square minus 4 plus 4 into ex, and in second we used to do what? D square by minus a square, or you can say minus 2 square. Okay, so it is minus 2 square minus 4d plus 4. Okay, so minus 4 cancel, or here it would be minus 4, so it is also cancelled. Okay, and here you are having sine 2x. So now you see it is equal to we get 1 upon 1, so which is equal to 1. So 1 into exponential x is equal to ex, and you see here we are left with minus 4 d sine 2x. Okay, so if I take it out, I can write it as minus 1 over 4 and 1 by d sine 2x. We did initially that d 1 by inverse operator of d, or 1 by d, is nothing but integration. So instead of this I can write integration sine 2x with respect to dx. So we know integration of sine 2x is minus cos 2x divided by 2. So it would become plus 1 by 8 cos 2x, right? So this is yp. Okay, so complete solution y is equal to yc plus yp. Okay, you just write it by yourself. Okay, I have drawn the I have found out this yp and yc. Okay, you just write the solution now, complete solution. Okay, complete solution. So one last problem now on this rule. Okay, then we will be doing rule 3. Okay, so third problem, solve d square x square, okay, plus I'm sorry, it is negative. Okay, minus 4 dy over x plus 3 y equal to sin 3x cos 2x. Okay, so symbolic form you are going to write it by yourself, and complementary solution you are going to find out by yourself. I'm writing it shortly. Okay, complementary solution in this case, when you are going to find it out, roots of this would be 1 and 3. So in this way, complementary solution would be c1 e raised to power x plus c2 e raised to power 3x. I'm going to find out particular integral directly. Okay, so particular integral would be equal to 1 over d square minus 4d plus 3, okay, into sin 3x into cos 2x. Since we know we don't have formula to such product of a trigonometric function, so we will have to separate this. We know sin a cos b is equal to half of sin a plus b minus sin a minus b. Okay, we know this formula, right? So therefore we can write this as d square minus 4d plus 3 into, instead of this we can write sin half I'm writing outside of this, sin 5x addition minus sin x only. Okay, so now it can be written as 1 d square minus 4d plus 3 sin 5x minus 1 over d square minus 4d plus 1 sin x. Okay, so 1 by 2. So now you see we can replace d square by minus 5 square, which is equal to minus 25, right? So minus 25 minus 4d plus 3 sin 5x minus, okay, in this we are going to replace d square by minus 1 square, which is equal to minus 1. Okay, so minus 1 minus 4d plus 1, right? So minus minus cancel, minus plus cancel, and we are left with this only. Okay, so it is equal to 1 upon 2 1 over minus 4d minus 22, right? Sin 5x minus 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 plus 1 by 4 1 by d into sin x. Okay, 1 by 2 I can take minus sign outside, and 1 by minus 2, so I'm left with 2d plus 11, right? Sin 5x plus 1 by 4, so integration of this, okay, because 1 by d stands for integration, so integration of sin x is equal to minus cos x. Okay, so now we need to solve first part only. In order to solve this, we are going to multiply and divide by 2d minus 11 2d minus 11 into 2d plus 11, okay, into sin 5x plus 1 by 4 cos x, okay, negative sign here. Okay, so now if we take this minus sign outside, we get outside what? Minus 1 by 4, so it would be 2d minus 11 divided by 4d square minus 121. Okay, sine 5x. So minus 1 by 2 outside, so it would be, we are left with 1 by 2 inside. Okay, cos x divided by 2. Again you can change d square by minus 5 square. Okay, so 2d minus 11 divided by 4 minus 5 square minus 121 sine 5x plus cos x by 2. Okay, so minus 1 by 4. So solving this, it would be minus 100. Okay, minus 100 minus 120, which is equal to minus 221. Okay, into sine, into 2d minus 11 sine 5x plus cos x by 2. Okay, so nextly it is equal to minus 1 by 4 minus 1 by 221 2d sine 5x minus 11 into sine 5x plus cos x by 2. Okay, so it would be minus 1 by 4 minus 1 by 221. So it would be, after differentiation, d stands for differentiation. Okay, it would be 10 into cos 5x. Okay, minus 11 sine 5x plus cos x by 2. Okay, listen, I did something wrong here. Okay, so here I wrote by mistake 1. Okay, here I wrote by mistake 1, but it is 3. Okay, you just correct this, so you would be you would be having 3 over here. Okay, 3 minus 2, so it would be not d only, but you would be having minus 4d plus 2. Okay, right? So you just correct this. So in this way you will be having something different in place of this. Okay, definitely you will be coming with other answer. Okay, I wrote 1 in place of 3. Okay, you just correct it. Okay, so rest of the things are same. Okay, in this way we have found out the particular integral. You just multiply it by multiply with this minus 1 by 4 inside. So in this way you will be getting 1 over 884 cos 5x minus 11 sine 5x. Okay, plus minus 1 over 4 into something here. Then you find general complete solution by adding yc and yp. In this you will be able to get your result. So which is the solution of required solution of given differential equation. Okay, so with this we end this rule, right? Rule number 2. In next video we will be discussing rule number 3. Okay, which will be dealing with x raised to power m, right? And in that rule we will be using binomial theorem, right? And so we end this lecture here. Okay, so see you tomorrow. Thank you.